All right, 4.5 dilations. The first thing to go through is some vocabulary. First, a dilation. A dilation is a change in size of the preimage. Okay. Please note that the angle measures will not change when you're changing size. They stay the same. Okay, that is a dilation. A center of dilation. The center of dilation is the point at which you are projecting from. Okay, so center of dilation is the point at which we project from. If your shape gets smaller, it's a reduction. If it gets larger, it's an enlargement. Okay? And when I'm talking about scale factor tells you how much bigger or smaller it is getting. Okay? How many times, maybe rather than how much, how many times. Okay, how many times bigger or smaller. So, and we call that scale factor K, by the way. And since our shapes are changing size, it's not a rigid motion. These dilations are not rigid motions. They're referred to as non-rigid because they change size. So let's look at some of these. So if I have my preimage, this shape right here, it's my preimage. It's what I start with. And I'm dilating from the center of dilation. I am actually getting smaller, so we call that a reduction. Okay. When you're getting smaller, it's a reduction. Let's give it some values here so we can come up with a scale factor. Let's say from this left vertex down to the center of dilation, let's say that has a length of 6. Okay, let me switch up colors here. Let's say from the center of dilation out to this vertex has a length of 3. Well, when you're trying to find out your scale factor, you're comparing 6 to 3. And when you compare 6 to 3, really you have two options. You can say, okay, it's 6 to 3. You can compare that way, or you can compare it at 3 to 6. You just flip it over. And what you have to do, well, at least what I do, is I look at it and say, well, am I getting bigger or smaller? Because if I'm getting bigger, the amount that my scaling by has to be greater than 1. So if I'm enlarging my figure, an enlargement, K, is going to be bigger than 1. If I'm reducing my figure like I am here, K has to be between 0 and 1. Okay? And so when I look at these two numbers, I go, well, 6 over 3 is actually 2. 3 over 6 is 1/2. If I'm reducing, I have to pick the one that's between 0 and 1, and that is this one here. So my scale factor for this shape is 1/2. It is not 2. Okay, so let's try that on a different one. Let's say I have my preimage, once again, same color, and now I have my image up here. Okay, so let's give these some numbers. Let's say my image this time is 10 units away. Okay, and we'll stick with our preimage being 6 units away. Okay, so we know that we're getting bigger, so it's an enlargement, meaning the scale factor has to be greater than 1. So once again, I have two options. I have 10/6, or I have 6/10. Well, which one's greater than 1? Well, hopefully right away you recognize 6/10 is smaller than 1 because the numerator is smaller than 10. So that one won't work. The numerator is smaller than the denominator. The smaller number's on top, so it's less than 1. Since the bigger number's on top here, that means it's greater than 1. 10/6 actually reduces to 5/3. My scale factor, or K, equals 5/3. All right. So knowing that information, let's go ahead and try some different things. A couple problems here. Use the graph of triangle A being at 2, 4, B, 2, 1, and C, 3, 1. So we've got that graph here. To graph its image after a scale factor of 2, centered at the origin. Now, anytime you're given a grid, and if they don't tell you where it's centered, always assume that you are projecting from the origin. You are centered from the origin. So our center of projection, or our center of dilation, is right here at 0, 0. Okay? And really, if I'm going a scale factor 2, that means every point is being projected out 2 times as far. In other words, really what you're doing is you're coordinates by 2. You're multiplying this by 2. Okay? Let's actually put that 2 right here. So saying, okay, 2 times 4, that's 8. 2 times 2, that's 4. Okay? A prime. Okay, I'm multiplying this by 2. Four and 1. That's B prime. And multiplying this by 2. Okay, 6 and 1. And that is C prime. When I plot those points, 4, 8, there's A prime. 4, 1, there's B prime. And 6, 1, there's C prime. That shape right there has been dilated by a scale factor of 2. Okay. Note that each side is 2 times as big as the pre-image. So BC was 1, it's now 2. AB was 3, it's now 6. Okay. Let's go ahead and try another one. All right, so use the graph A 410, B negative 25, and C 45 to graph its image after a scale factor of 1/2 centered at the origin. So once again, we're centered right here. Okay, we're now scale factor 1/2, so that means we're multiplying each of these by 1/2 now. Okay, so A prime looks like it's going to be 1/2 of 4 is 2, 1/2 of 10 is 5. B prime is going to be, well, multiplied by 1/2. Half of negative 2 is negative 1. Half of 5 is, well, 5/2, or 2.5. And then C prime, well, half of 4 is 2. Half of 5 is 2.5. Okay, so if we plot those, 2, 5, there's A prime. Negative 1, 2.5, and B prime, and 2, 2.5, and C prime. There is our new figure there. Let me go ahead and set that line a bit. All right. So we've got triangle A prime, B prime, C prime. Note that this side length from A to C, it was 1, 2, 3, 4, 5. It's now 2.5. This side length that was 2, 4, 6, or excuse me, 1, 2, 3, 4, 5, 6 is now 3. Okay, it has been reduced in dimension by 1/2. All right, let's go ahead and try another one here. Find the coordinates of the image of a polygon after dilation with the scale factor of k. Okay, so we have polygon QRST, QRST. So we are going to find Q prime, R prime, S prime, and T prime. And the way we're going to do that, well, we've got to multiply this whole set by negative 3. Okay, so I'm going to go 4 times negative 3. It's going to give me negative 12. Negative 3 times negative 3 is negative 9. 4 times negative 3, negative 12. 10 times negative 3, negative 30. 9 times negative 3, negative 27. I better give myself a little more room here. 12 times negative 3, negative 36. 10 times negative 3, negative 30. 6 times negative 3, negative 18. So my new coordinates, when multiplied by a scale factor of -3 is Q being -12, -9, R being -12, -30, S prime -27, -36, and T prime -30, -18. I meant Q prime and R prime here. Okay, and if you look at it and you go, whoa, a scale factor of negative, what's that mean? Scale factor of negative means that you actually are rotating your figure 180 degrees and then doing the dilation. So you're enlarging it or reducing it after you rotate it 180 degrees. All right. Well, okay, find the scale factor of the dilation. Well, the first thing I want to ask myself when I'm looking at a figure and trying to figure out the scale factor is, going from the pre-image to image, am I reducing or enlarging? So reduce or reduction or enlargement. Okay, well, if I'm going from JKLM to J prime, K prime, L prime, M prime, notice I know I'm going from pre-image here, pre-image to image, because this is J and this is J prime. The primes are the image. So that means my figure is getting bigger. So I am dealing with an enlargement here. Meaning when I'm comparing sides, I'm looking at, I have options. I have 3/12, or I can have 12/3. Well, notice 3/12 goes with a reduction because it's smaller than 1. 12/3 goes with my enlargement because it's greater than 1. This is 4. This is 1/4. Therefore, my scale factor in this figure is 4. Okay? We don't need the reduction because we're not getting smaller. That's kind of how I figure it out. So if I'm looking at this next one, I'm going, okay, scale factor. Well, first, is it reducing or enlarging? Okay, well, I look at it, I'm going from, well, here's J and here's J prime. So my figure is getting, from pre-image to image, it's getting smaller. So this is a reduction. So I don't need any enlargement. Okay, so it's a reduction. And then I'm comparing 2 to 10. 2 is to 10, which is 1/5. That is between 1 and 0. Whereas the other route would be 10 is to 2, which is 5, which we obviously don't need here. Scale factor, 1/5. All right, well, that's all I got for you. Good lucky.